Anyone still using IE 6 or 7? We have one, man, two. You can, hi, my name is Kent and I am an IE 6 user. It's okay.
So I depend on it. I like my style, expression, filter, evasion techniques.
Yeah, exactly. Even if you're doing proper output encoding, IE 6, IE 7, IE 8, IE works mode, even if properly encoded, IE will decode it and execute it if it's an expression. It's just the word where the untrusted data goes. It's just the word expression, and then between the round brackets, some JavaScript. So, honestly, Matt, you're 100% right. Avoid letting users drive style. It's not a real good, safe way to do it. There's not a really sensible reason to do it in most corporate websites. And I say design around the issue. If you want to let the user change the font size, do what most news sites do. Give them a widget to increase and decrease their font size. If you want them to pick from different styles, then you as a developer build a series of trusted styles and let the user choose from one. It's a much safer way to roll. Next slide. DOM. This is DOM-based XSS. This is when you're assigning untrusted data to a JavaScript variable. This is incredibly common. We do this in Ajax every day. In this case, we want to make sure it's quoted, first of all, even in numeric, and we do JavaScript text output encoding. The problem is what happens to that JavaScript variable after the assignment. We have DOM-based XSS. Next slide. So here we have the untrusted data, again, going into a code execution context. We can never do this in a safe fashion. And we need to give developers some guidance to really deal with these deep Ajax and JavaScript issues in a safe fashion. Here's a couple of them. We have untrusted data should only be displayable text. Do not let your users drive workflow variables or other things that drive the structure of your page. Only let untrusted data drive something that's display text. It's a safer way to roll. Go back for just 1 second. We also want to We also want to make sure that we're doing proper JavaScript encoding. We also want to make sure that we're using only the safe APIs and only safe attributes. Avoid the HTML rendering methods like inner.html or jQuery.html. And also be careful with any code execution context. The eval, the timeout, on-click, on-blur, there's quite a few of them that will always pop when untrusted data lands in that context. And also, here's the hard part. When you're doing really advanced JavaScript, next slide, you have to do contextual encoding within the DOM itself. This is the most popular language known to man in the world of JavaScript, jQuery. It makes advanced JavaScript programming really easy, one line. But here's the problem. Almost every single API in jQuery is vulnerable to XSS. They're not doing any kind of sanitization in their library. And when we talk to the jQuery developers and ask them to do it, guess what they say? Talk to the hand. No way, we even think about this. So you really want to do deep security coding? Holy cow, you have to do, next slide, contextual encoding within the DOM, within JavaScript itself. So we have the jQuery plugin from Chris Schmidt that will let you do contextual encoding within jQuery itself. This is when you have an attack that lands on a page. The page is not popping yet, but based on dynamic behavior that the user is choosing on the page, that data goes from, say, a drop-down menu to a text field or to some other variable. As that data moves through the DOM, you may have to apply contextual encoding in the DOM itself. So jQuery has a plugin to do that contextual encoding. Next.
So we're going to move on to CSRF, past XSS. That was, again, the 88 mile per hour XSS defense talk, right? But CSRF, we didn't really talk too much, but that vulnerability I showed you before was vulnerable to CSRF because we can fake that post request on my own malicious site, force a user to submit it to the domain, and they're only checking their identity via the cookie, and that's really the problem, right? So we need to add layers beyond the cookie, beyond the headers, which are stored in the browser. That's why this vulnerability exists, and that's why we're going to talk about tokenization.
Just real quick now, my favorite defense for cross-site request forgery, as much as the tokens are necessary, I'll get to that in a second, my favorite defense is a simple technique called re-authentication.
We use Amazon.
Amazon.
So, yeah. How many times you got to log in, right? To move through the checkout process, you got to re-enter your password a few times, right? A lot of businesses aren't willing to make that user experience trade-off, right? They don't want to force someone to re-enter their password. CAPTCHA, I'm not going to get into it, not a CSRF defense, not a valid CSRF defense. CAPTCHA is breakable, has been broken time and time again, right? So password, perfect, re-authentication. Most common place you see it, the most common place some people forget it actually, reset password functionality. 2 text boxes, vulnerable. 3 text boxes, good, right? Oh, reset my password. What do you want to reset it to? Oh, let's make sure you didn't typo. What's missing? Your current password, right? Please enter your current password. If I can CSRF you into changing your password, who needs any other hack, right? I got your account, right? So that's probably the easiest place to implement it where user experience really isn't affected at all.
And again, I'm not selling Amazon, but I think they got it right because they have a great balance between usability and security. If you're a frequent user of Amazon and you go in just to fit and you already have a profile set up, you're purchasing a book, you go in, pick your book, check out, pick your payment, and you're out. And you only have to log in one time during the financial checkout part of the process. The only time you get bugged for additional authentication is if you're shipping an item to an address that you've never shipped an item to before. That's a perfect place to double check. Or if you're changing your credit card information, or if you're changing your email address or your account information. These are things you don't do that much in a normal workflow. It's a special case. And if someone can get a hold of your session, they can do a lot of damage. Amazon, they're in the back, high five, they did this a perfect balance, in my opinion, between usability and security. Good job. And so I kind of like to mimic that when I recommend e-commerce workflows, what Amazon does.
But it's not. Tokenization, you want to touch on it?
The other defense is we got to make endpoints in the web random. So what we do is at the time the user first logs in, we use like Java Secure Random or one of the different PHP random classes of your languages to build a long 64-byte or so random value. And at the time of login, stick it in the session, a trusted location. Every time we build a form for a user, we want to grab that token out of session and put it in as a hidden variable. And every time that form is then submitted back to the server, we rip the token out of a token variable, we compare it to what's in session, and if they're equal, we let that request go through, otherwise we reject the request and maybe lock the account or take other action. This is not a perfect defense, it's got problems. It's the best that we have today in most every framework I've seen out there. It's got this added to the framework in some way.
Two common mistakes, I just want to warn before we move on. Two very common mistakes I see all the time after people go through all the work of implementing a CSRF token. 2 common mistakes. One, they put it in the header. They make it a cookie. It's just another cookie. It's stored in the browser. That's the crux of the problem. You have to put it in the form that's being submitted, right? Other defense, they're not checking it server side. What's the first thing I do when I see a CSRF token as an attacker? I empty the string. Empty it. Completely delete the whole thing, submit the form. A lot of times still valid. 2 very common mistakes. Please watch out for.
How often do you see someone doing a token without validating on the server?
Too often. I don't understand it because you put in all this work to, it's actually much harder to create the token and implement it into your forms than to actually, they're storing it in the session, they're storing it properly, and they just don't even look at it after you submit it. It's like, okay.
If token is valid, somebody can put that in there.
So, lesson learned, a lot of this stuff is easy once the education is in the right hands. XSS is a little bit complicated, right? SQL injection pretty easy, CSRF pretty easy. When it comes to actually implementing these things versus the vulnerable way to implement it, it's just all about education. We have to go educate the people writing this code. They're not going to come to us as security professionals to be like, how can I write more secure code, right? So just moving forward, we want to leave on a positive note, not doom criers here, right? They're not going to come to us. This stuff is being taken more seriously. Thanks, Anonymous. Many of you are here. Thank you. This stuff is creating budget for a lot of us, right? I'm sure a lot of us have created jobs. Being taken much more seriously. Another hat tip, Jeremiah, hack yourself first, right? Like, we have to be protecting ourselves before the bad guys do. And then Jim, your favorite?
Build security in.
Move it earlier into the SDLC, right? Where does it happen right now? When code's in production. This is an uphill battle, right? Build it in the requirements phase, in the design phase, in the QA phase, in the education phase. Post-production, if that's the only place you're doing it, you're doing it wrong.
The best statistics I've seen that say, if you're trying to add security into web application at the end, after it's all being built, versus adding requirements, design, and good security from day one, the cost to fix an individual bug is hundreds, if not thousands of times more expensive at the end of the SDLC in some situations than if you just designed it and secured it in the first place. So, you know, web application security, it was debatable whether to invest in security. If you're monetizing off your website, if your website matters to you in some way, if someone said that here's a good risk model, is it important? Then secure it. So these days, web applications are one of the most commonly used vectors for attack in the real world. This is not theory, this is what we see every day. And so I really believe we have to enter an era where we care about website security development more. The earlier you do it, the cheaper it's going to be. Hey man, build security in from day one. It's going to have a benefit to you as a developer, it's going to benefit the company you work in, the department you work in, your customers benefit. Happy unicorns. Everyone benefits.
Back to the unicorns. Absolutely.
Let's try that.
Any questions? We're kind of over time, but if we take one or two, if they're over there, yeah. They're there. If not, we're floating around. If you want to talk attack, I'm happy to. If you want to talk defense, I'm also happy to. He's your guy. Anything? Cool. Thanks, guys.